Polymorphism. Okay, it's a big word, I get it. But it stands for a really, really simple and beautiful idea. And honestly, mastering this is what separates brittle, rigid code from truly flexible, elegant software. So in this explainer, we're going to strip away all the confusing jargon and show you how this one concept is going to fundamentally change the way you build things.
So here's our game plan. We'll kick things off with a simple promise. Then we'll look at the two main types, or flavors, of polymorphism. After that, we'll see the real magic of method overriding in action, and we'll connect that to why it's so critical for building real-world software. And we'll wrap up with the one key takeaway you need to start using this yourself.
To really, truly get polymorphism, we're not going to start with a bunch of code. Nope. We're going to start with a single, simple idea. Something you've probably already experienced a million times. Right, this call center is the perfect analogy. Think about it. When you call, you only care about one thing, that main support number. You don't know, and frankly, you don't care if you end up talking to Bill from billing or Tess from tech support. You just trust that whoever picks up the phone can handle your request. One number, many different specialists. That's the core idea. Just hang on to that thought.
And here it is, the textbook definition. The word literally means many forms. You got poly for many and morph for forms. So it's just a principle that lets one name, like our one support number, stand in for many different actual behaviors, like all the different specialists who can solve your problem. It's how we write one piece of code that can do many, many different things.
So how does this actually show up in our code? Well, it comes in two main flavors. One is pretty simple and static, but the other is dynamic. It's powerful, and it's the one we're really going to focus on today. Let's just quickly look at the difference.
Okay, so on the left, you've got compile time polymorphism. This decision is locked in by the compiler before your program even runs. It's like having two methods both named add. One adds numbers, one adds strings. The compiler sees your code and knows exactly which one to use. It's static, it's predictable. But on the right, well, that's our main event, runtime polymorphism. Here, the decision about which code to run isn't made until the program is actually running. The JVM figures it out on the fly. And that flexibility is what makes truly powerful, adaptable software possible.
And this brings us to method overriding. This is the engine that makes runtime polymorphism go. So let's translate our call center idea directly into code and see this magic happen right before our eyes.
First things first, we define our one number. In the world of code, this is an interface. You can think of it as a contract or a set of rules. All it says is, hey, anyone who wants to be a support handler must have a method called handle. It doesn't care how you handle it, just that you promise you can.
All right, now we hire our specialists. We create a billing handler and a tech handler. And notice, they both agree to follow the rules. They both implement our support handler interface. Each one provides its own unique, specialized version of that handle method. The billing guy knows about orders, and the tech expert knows about app issues. Same job title, different skills.
Now this is the most important part. Look at this line of code. We declare a variable of the general abstract type support handler, but then we assigned it a very specific, concrete object, a new billing handler. We're treating a specialist as a generalist. We're telling our program, hey, I've got a support handler for you, and just so you know, right now, it's the billing person.
And here is the payoff. When our main code calls handler.handle, it has no clue it's talking to a billing handler. All it knows is that it's talking to some kind of support handler. But here's the cool part. At runtime, the JVM is smart. It peeks inside that handler variable, it sees the actual billing handler object sitting there, and it says, ah, I know exactly what to do, and it runs the specific billing code.
But now, watch this. This is the magic trick. We take that exact same variable, handler, and we just point it to a new tech handler instead. The specialist on duty has just changed. And now, when we call the exact same line of code as before, handler.handle, the JVM does its little peek again. But this time it finds the tech expert and runs the technical support code. One variable, one method call, two completely different results. That is the power of runtime polymorphism.
Okay, so that's a really cool programming trick, right? But why do we care? Why is this considered one of the absolute cornerstones of modern software design? What does all this flexibility actually get us?
The benefits are, well, they're huge. First, your code becomes super extensible. You could add a brand new sales handler or a returns handler tomorrow without touching a single line of your main core logic. That's possible because of something called loose coupling. Your main program isn't all tangled up in the details of billing or tech. It just trusts the support handler contract. And this immediately gives you cleaner code. You get to throw away those awful, complicated if-else chains that are always checking, is it this type, is it that type? And all of this together, it enables what is basically the holy grail of software design, a true plug-in architecture.
This is the perfect real-world example. Imagine a payment system. It needs to handle credit cards, PayPal, bank transfers, you name it. The core system just knows it's talking to a generic payment processor. You could add a totally new crypto payment method tomorrow, and the main system doesn't need to be changed at all. That is incredibly powerful stuff.
So, we've walked through the analogy, we've seen the code, and we've talked about the benefits. Let's boil this whole thing down into a simple, repeatable process that you can actually use.
It really just comes down to these 3 steps. Number 1, define your contract, that common interface or base class. Number 2, write your main code to talk to that general interface, not the specific, concrete classes. And number 3, just sit back and trust the JVM to be the smart router, connecting the call to the right specialist when the code actually runs. You just define the what, and you let the system figure out the how on the fly.
And that pretty much brings us to the end. The core idea is just so simple. One name, many forms. It lets you build systems that aren't just working for today, but are adaptable and ready for changes you haven't even thought of yet. So I'll leave you with this question. Looking at the code you work on every day, where could this plug-in style of flexibility make the biggest difference? Where could it simplify things for you? Think about it.